Hello again. Welcome back for section 2 of chapter 1 titled Slopes of Lines. Everybody loves that word they hear in their math classes. You've been hearing it since you were in pre-algebra. Slope. Now, slope is pretty simple. Most of us are familiar with it by now. The slope is a measurement of how steep a line is. S-T-E-E-P, of how steep a line is. Another way to think about it is a rate of change. For instance, you may travel 30 miles per hour on your way to school, or Mr. Williams might eat 20 pizzas per day, which was probably true back in college. But anyway, it's a rate of change. It's a measurement of something happening versus a measurement of something else happening. Some people like to think of it as rise over run. That's kind of a measurement of what's happening pictorially speaking. Now that we're in honors pre-calc, we need to start doing things the nerdy way. We could also say it's delta y over delta x. That triangle is a Greek letter delta. Delta means change. Or, here's a cute little formula. It's the change in the y values of the coordinates involved, y2 minus y1 over x sub 2 minus x sub 1. So the change in the y's over the change in the x's. So what I want to do is draw our first line down here on grid number 1. Let me go ahead and get rid of all this stuff and give us a little room to work. I'm going to put a dot at 2, 0. And I'm going to put a dot at 5, 3. So right 5 and up 3. And if you want, you can even connect the dots. In fact, I recommend you do that. Get my line so that it goes right through them. So there we go. Find the slope of that line. Now, is that a positive slope or is that a negative slope? Well, that's relatively simple. Okay, you would do the change in the y's, that would be 3 minus 0. Now, notice this order doesn't matter, over the change in the x's, which is 5 minus 2. So 3 minus 0 on top, that is just 3. 5 minus 2 on the bottom is 3. So that slope ends up just being 1. It rises 1 unit for every 1 unit that it rises, or 1 over 1. Now notice, had you done 0 minus 3 over 2 minus 5, which is perfectly fine, you get negative 3 over negative 3, which is also positive 1. Awesome. Okay, jump over to the second grid. Let's put a dot at 1, 3 right here. I'm picking nice, pretty points, not being too difficult on you. And 4, 1, right about here. 1, 3, and 4, 1. Draw a line. One, 3, 4, 1. Trying to get my line to look good. It's not terrible. Anyway, find that slope. Go ahead and do that. You probably don't need my help to do it. Do your change in y's on the top. The second y was 1. The first y was, what was it, 3. On the bottom, the change in x's, you'd have the second x was 4. The first x was 1. Okay, so you get negative 2 on the top. 4 minus 1 is 3 on the bottom. Negative 2/3 cannot be reduced. So guess what? You done. That's all you can do. Your slope is negative 2/3. It's a negative slope. The line is decreasing. It falls 2 units down for every 3 units that it runs. So for instance, maybe you lose 2 pounds every 3 days if you're on a diet plan or something like that. That could be your slope. Here is number 3. I want you to put a dot at 1, 3, so right about here, and put a dot at 3, 3. Just do your best in your notes. I know that you may not have perfect graphs, but as long as they're pretty close, that's all that matters. That's all I'm looking for. All right, draw that line. That connects them. Just like so. Hey, this is a horizontal line. All right, this is actually the line, and you need to know this. This is the line y equals 3. Notice how a y equals line goes side to side. An x-equal line will go up and down. That's something you need to get memorized right now. One easy way to remember it is y-equals lines always go through the y-axis. Remember, the y-axis runs vertical, but y-equals lines run horizontal. All right, let's find this slope. Now, the y values are the same. They're both 3. So 3 minus 3 over the x values, 3 minus 1. So you have 0 over 2. Well, last time I checked, 0 divided by anything is just 0. We say that this line has 0 slope, i.e. it's a horizontal line. Any line that's horizontal always has 0 slope. It's not positive, it's not negative. All right, last example. Get rid of this stuff here, get it out of the way. Okay, let's go to example number 4. Now here I want you to put 2 dots at the ordered pairs 4, 4, 4, 2. Do the same thing, draw your line. I'll just draw this one in. This time we got a vertical line. Now if the last one was a y-equals, guess what? Vertical lines are always x-equals. That sounds like a good quiz question. What do x-equals lines always look like? Are they horizontal or are they vertical? Make sure we know that one. All right, find the slope. Use your handy-dandy formula, change in y's. The y's here, let's see, let me put these ordered pairs in here just to help myself out. This was the point 4, 4. This was the point 4, 2. So the y's would be 2 minus 4, or 4 minus 2, it doesn't matter, over 4 minus 4. Alright, 2 minus 4 over 4 minus 4, that's negative 2 over 0. And negative 2 over 0, what is that? Well, type in negative 2 divided by 0 to your calculator. Try it. Type in negative 2. What happens? You know what happens? Your calculator like blows up in your hand and it says, what are you trying to do to me? I can't do this. Negative 2 divided by 0 is impossible. It's undefined. Alright? There's only one person in the world that can do negative 2 divided by 0. Do you know who that person is? If not, you're about to find out. It's this guy. You know who he is? That's Chuck Norris. I don't know why the lights go out. Anyway, if you'll read fact number 2, Chuck Norris can divide by 0. Last time I checked, you're not this guy. So he can divide by 0, you cannot. That is all. Okay, so in this next slide, I want you to graph a couple lines on both of these graphs. So the first graph, you're going to graph the line y equals negative 2x plus 2. Graph that line. It starts up 2, then it goes down 2 because this has a negative slope, and right 1. Down 2, right 1. Down 2, right 1. Or up 2 and left 1. Graph that line, make it look as good as you can, make sure it looks better than mine. Okay, and then I want you to graph the line y equals 1/2 x minus 2. That starts down 2, since the y-intercept is negative 2, and it goes up 1 and right 2. Up 1, right 2, up 1, right 2. Or down 1, left 2, down 1, left 2. And connect the dots there. Now, notice here, these lines cross each other, don't they? And they cross each other at a very, very special angle known as a right angle. And when something crosses at a right angle, you can draw in that little box. Now, why is that? It has to do with the slopes. One of the slopes was 1/2, and the other slope was negative 2. Now, notice, I'm pulling the slopes from this guy right here. That's negative 2. Here's 1/2 right there. See them? Those are the slopes. Negative 2, 1/2. When the slopes are opposite reciprocals like that, you end up with perpendicular lines. That upside down T, that's the symbol for perpendicular. On the other graph the line y equals x plus 1. Well, that just starts at 1, and its slope is 1, so it goes up 1, right 1. The slope is 1 because that's the number in front of the x. It's 1 over 1. So graph that line. and then graph the line y equals x minus 1. So he starts down 1, and his slope is the same, so he also goes up 1, right 1. Does something like that. Now what do you notice about those lines? Well, they have the same slope, don't they? The first slope was 1, and I'll draw an arrow, and the second slope was also 1. So that means we ended up with parallel lines. Lines that will never cross in the two-dimensional plane. Now, you guys know that parallel lines never cross. That's actually not always true. When you get outside of the world of Euclidean geometry and you get into non-Euclidean geometry in a class like projective geometry, parallel lines actually cross at a point known as infinity. But anyway, that's for you math nerds, which most of you are. So anyway, one last thing before we do a couple examples. That's slope-intercept form. Last section we talked mainly about standard form. That was ax plus by equals c. This section I'm going to introduce slope-intercept form a little bit more. You guys know it as y equals mx plus b. Or, in this class, sometimes it'll be known as y equal mx plus k. Okay? Where m is always the slope of the line. Could be positive or negative. And b, or k, is always the y-intercept of the line. It's where the line crosses the y-axis. Notice it could be b or k. Now, let's do example, I guess you could officially call this example number 1. And my directions to you are to find the slope and to find the y-intercept. Here's the line. 13x plus 9y is equal to negative 33. And I want you to find the slope and the y-intercept of this line. Now, do you know either one of those yet? Do you have slope-intercept form? Well, the answer is you don't. To have slope-intercept form, y has to be by itself. So what we're going to do is we're going to take this 13x, we're going to pick it up positive and drop it off on the other side. But don't drop it off positive, drop it off negative. It's just like subtracting 13x. And 9y is sitting right here. Now, y is almost by itself. Divide both sides by 9, just like so. Reduce if you can, which you can't, at least as far as the slope goes. You get negative 13 ninths. Now 33 ninths does reduce. You can divide both by 3, so you get 11 thirds. And there you go. That's all you can do. So tell me the slope. It's negative 13 ninths. Notice I put m equals. I want you to put that. And tell me the y-intercept. B or k, I don't care. Is negative 11 thirds. Now that wouldn't be very fun to graph, but as far as algebraically working with it, it's not too difficult at all. Okay, we're almost done. I got to show you a couple theorems, and then one more example, we'll be done. Two lines are parallel. So just do two sticks, vertical sticks, if their slopes are the same. In other words, if m1 is equal to m2, m sub 1 is equal to m sub 2. So for instance, if the first slope, was negative 3/4, then the second slope would also have to be negative 3/4. Pretty easy. If the first slope was football, the second slope would have to be football. All right, they always have to be the same. Two lines, however, are perpendicular, upside down T, if their slopes are opposite. How do you spell opposite? One or two T's? One T. Opposite reciprocals. In Algebra 1, I call it the opposite reciprocal. All right, so you have to flip and switch these slopes. In other words, M1 is really 1 divided by M2, and not only that, it changes the value of the sign, so it becomes negative. So, for instance, if M1 was negative 4/7, then M2 is, flip it, so it's positive 7/4. Notice it went from negative to positive. If the first slope, was, let's just say it's positive 1. Well, flip it. When you flip 1, well, you just get 1, but instead of positive, it's negative now. And let's say the first slope was, or M1 was negative 3. So it goes from negative to positive. Instead of 3/1, it's now 1/3. So make sure you flip and make sure you switch. All right, here we go. Last example, and then we're done. here's my question. I want to know in example number 2, get that out of here, blow this up just a bit. I want to know in example number 2, which lines are parallel and which lines are positive. I'm going to give you 3 lines. Here's line 1, L1. It is y is equal to 3/4 x minus 7. L2 is 4x plus 3y equals 10. And L3 is y is negative 1/4 plus 3/4 x. All right. Gorgeous. I want to know which ones are positive, which ones are negative. Now, what do we need to know? Do we need to know anything about the y-intercepts or anything about the slopes? We need to know about the slopes, which means we need to have slope-intercept form. So do we have slope-intercept form? Well, kind of. We do on a couple of them. Here, this guy, y is already by itself, so the slope is 3/4, just to make that little note. The middle guy, he's not ready. Y is not happy. Y is not by itself. But the last guy, the slope is also 3/4. It's right here. Okay, and the middle guy, though, we need to get y by itself. So let's do that real quick. Y equals, pick up 4x, it becomes negative, divide by 3, negative 4/3 x plus, scoot the 10 down, divide it by the 3 on the y, 10/3. So that m is negative 4/3. And now we know everything we need to know. So tell me, which lines compare to which? Which lines are parallel? Well, which ones have the same slope? This guy and this guy. So we would say L1 is parallel to L3. And which ones are perpendicular? Which ones are opposite reciprocal slopes? Well, 1 and 3 are the parallel, but they're perpendicular to 2. So we would say L2 is perpendicular to L1, comma, L3, because it's perpendicular to both of them. That's supposed to be an L, not a funky looking whatever it is, balloon. I think that's it for section 2. I'm going to let you do the rest on your own. Make sure you invest in the time that you need to in section 2. Don't start the year off in a hole. I'm enjoying the year so far. I hope you guys are too, and I'll look forward to seeing you in section 3.